YAML. Ledoit Wolf shrinkage. Description estimates the shrunk Ledoit Wolf covariance matrix. This estimator uses the Ledoit Wolf shrinkage method to estimate the covariance matrix of the data. This method shrinks the sample covariance matrix towards the identity matrix, which can improve the accuracy of the estimated covariance matrix, especially when the number of features is large relative to the number of samples. Parameters. X. Description: the data matrix. The rows represent the samples and the columns represent the features. Type array. Assume centered. Description: if true, data will not be centered before computation. Useful to work with data whose mean is significantly equal to 0 but is not exactly 0. If false, data will be centered before computation. Type Boolean. Default false. Block size. Description: size of blocks into which the covariance matrix will be split. This is purely a memory optimization and does not affect the results. Type integer. Default 1000. This parameter can be either none, empirical, or a callable. If none, the shrinkage coefficient is estimated using the Ledoit Wolf method. If empirical, the shrinkage coefficient is estimated using the empirical Bayes method. If a callable, the callable should take the sample covariance matrix and the number of samples as arguments and return the shrinkage coefficient. Shrinkage. Description controls the shrinkage parameter. Type string. Default none. The following parameters are used to speed up computation. They are ignored if the shrinkage parameter is not none. The number of samples n samples to be used in the computation of the shrinkage coefficient. If none, all samples will be used. Default is none. The number of features n features to be used in the computation of the shrinkage coefficient. If none, all features will be used. Default is none. The maximum number of iterations to be used in the computation of the shrinkage coefficient. Default is 100. The tolerance for the convergence of the shrinkage coefficient. Default is 1e-4. N samples. Description: number of samples to be used in the computation of the shrinkage coefficient. Type integer. Default none. N features. Description: number of features to be used in the computation of the shrinkage coefficient. Type integer. Default none. Max iter. Description: maximum number of iterations to be used in the computation of the shrinkage coefficient. Type integer. Default 100. Toll. Description: tolerance for the convergence of the shrinkage coefficient. Type float. Default 0.0001. Returns. Shrink cov. Description: the shrunk Ledoit Wolf covariance matrix. Type array. Shrinkage. Description: the shrinkage coefficient. Type float. Examples. Dash. From sklearn. Covariance: import Ledoit Wolf shrinkage. Import numpy is np. X np. Array 0. 0. 1. 1. 2. 2. Shrink cov. Shrinkage Ledoit Wolf shrinkagex. Shrink cov. Array 0.66666667. 0.66666667. 0.66666667. 0.66666667. Shrinkage. 0.333333333333333333. Challenges. Dash. Challenge: how can you use the Ledoit Wolf shrinkage method to improve the accuracy of your estimated covariance matrix? Fix: by shrinking the sample covariance matrix towards the identity matrix. The Ledoit Wolf method can reduce the impact of outliers and improve the accuracy of the estimated covariance matrix, especially when the number of features is large relative to the number of samples. Dash. Challenge: what are the limitations of the Ledoit-Wolf shrinkage method? Fix: the Ledoit-Wolf method can be computationally expensive, especially for large datasets. It may also not be appropriate for all datasets, as it assumes that the data is normally distributed. Challenge: how can you choose the best shrinkage coefficient for your dataset? Fix: the Ledoit-Wolf method automatically estimates the shrinkage coefficient based on the data. However, you can also manually adjust the shrinkage coefficient to improve the accuracy of the estimated covariance matrix.